Hello, good afternoon. It's MoNaCo here. We're doing our second to last video in our measurement unit. We're talking about matter and separation today. So we're looking at page 26 and 28, 27 and 28 in our pack. We're going to be talking about separation techniques. We've got to be able to know how to separate different forms of matter. So we start off with a little bit of notes. So separation by density, we've all seen oil and water not mix, right? So for example, if you let this mixture sit, the more dense liquid, in this case water, will fall, and the less dense liquid, oil, is going to rise. A separation by density is very simple and easy to do. Usually we call that a flotation. Certain things float. They'll float to the top of the water and we can skim them off, and we have a separation of a mixture of matter. Now, separation by solubility is another one that we've all probably done before. If you've ever made coffee, you've done this. Or in school, perhaps. Salt and sand mixed together is hard to separate unless you realize that salt dissolves in water and sand does not. So if you dissolve the salt in the water, by adding water that is, stir it around, then pour the water and salt mixture off, you're left with just the sand, or you filter it out is a way it's called. So it's called a filtration or a decanting. We'll focus on filtration. Now this is other one's a nice interesting one, separation by boiling point. We do an evaporation followed by distillation. So this alcohol and water mixture. This is how they make more concentrated spirits and rubbing alcohols and other things for medical uses. The boiling point of water is 100 degrees. The boiling point of alcohol is about 85. You can see there's a difference there. So if you heat a mixture of water and alcohol up to about 86, 87 degrees, the alcohol starts to boil and the water doesn't. So you collect the alcohol vapor and cool it back down into a liquid in a different location. It's called using a distillation column or a condenser column. You get the liquid alcohol in a different beaker and the liquid water back where it had begun in the first place. It's kind of cool. We're going to try and have apparatuses set up for you to inspect and draw and diagram in your journals for these things because they're kind of cool to look at. Other types of physical separation are things like molecule size and magnetism. Iron filings and sand. Okay, iron is magnetic. So if you hold a magnet over the mixture, it'll attract the iron filings, effectively separating the two because sand is not magnetic. Okay, so you can do other types of separation physically. The big takeaway here is that you can separate a mixture using a physical technique. You can physically separate mixtures. Here's some pictures of imagery to follow along here. Filtration is a physical separation. Undissolved particles remain on the filter paper. The filtrate, the stuff that dissolved in the water, flows through the paper. This is good for separating heterogeneous mixtures, things that you can visually tell that it's a mixture, like sand and salt or sand and water mixture. The next one we're going to talk about is another physical separation. Notice the trend, the pattern here. Watch glass. It's separate solute, dissolved solid from solvent by boiling the solution. Solute escapes very limited precision. So if you have salt and water mixed together and you want to evaporate off the water, you do a watch glass evaporation. So the water leaves, salt stays behind. It can separate a homogeneous mixture, okay, like salt water or sugar water. It looks the same all the way throughout, even though you know there's some salt or sugar dissolved in there. The last type of separation we're going to talk about is another physical separation. Notice the trend. All mixtures can be separated physically. It's called a distillation. We separate the solute from the solvent. Stuff that dissolves in the solvent is called the solute, by boiling the solution and condensing in a receiving flask. Both solute and solvent are captured. We separate two or more liquids with different boiling points. So we mixture over on the left above the burner here boils. The vapor goes down the condenser, turns back to a liquid, and drips into the flask on the right. Okay. So this separates homogeneous mixtures, can be used to remove impurities from water. This is how a lot of our bottled water is actually created, from industrial byproducts. Yep, I said it, created and purified from industrial byproducts. That's often how bottled water and other drinks get the water. to mix with the other ingredients. So at this point, you should have some basic understanding of how to separate different kinds of materials. To do a YouTube search for distillations, filtrations, and or evaporations, you might get a tour of some factories that produce food that use these techniques in their manufacturing process. It was really, really cool to watch. It was one of my favorite things. It's like how it's made. How it's made, distillations, filtrations, evaporations. You can see a lot of really cool machines and work. Thanks for watching and listening.